Okay, I think we should go ahead and get started. The session is being recorded. Happy Friday, everybody. I want to welcome. Well, for those of you, I think everybody here, but Brittany is familiar with Sustainable Energy Hawaii. But I'll just go ahead and do a quick intro of the organization. SEH, or Sustainable Energy Hawaii, is a nonprofit dedicated to establishing affordable, sustainable, clean energy for Hawaii Island. This is a weekly talk story, and it's an opportunity for thinkers and tinkerers to share knowledge and make connections. We have someone in the waiting room. So today, I have the honor of introducing an amazing person. Actually, before we do that, let's just do quick intros. So Noelle Marin, I'm a board member of the organization. I'll go around the room real quick here, and then we'll end up with my introducing Brittany. So Peter, do you want to go next?
Sure. Likewise, board member, SEH.
Greg?
I'm an architect and carbon expert in California.
Thanks, Greg. Jerry?
Hi, Jerry Chang. I'm a former state representative and member of the Sustainable Energy Group.
Thanks, Jerry. Dan?
I'm Dan Goen from Electron Power and Technology.
Keith? Hi, Keith.
Left for a moment to get my headphones. Keith Neal, kind of out of breath because I ran upstairs. Yes, very much interested in energy transitions. This is kind of why I make my home here in Hawaii.
Excellent, Keith. John?
Land manager for several thousand acres, different landowners, in charge of hydroelectric power for Olson Trust at the coffee mill.
Thank you, John. Dave?
I'm member of SEH and fourth generation Big Islander, primarily in transportation and was in ag.
Thanks, David. Doug?
Hi, Brittany. Neither thinker nor tinkerer, and you and I have met by email.
Thanks. We have two other individuals. Jay Digmeyer?
Yes, this is Jim. Can you hear me?
Yes. Oh, that's
good.
Oh, good.
I'm the CEO of
Electron
Power Technology and hydrogen production.
Okay. You've got to mute one of your mics, but thank you. Thanks for joining us today.
Thank you.
So with that, I have the honor here of introducing an amazing person, a space systems engineer who's worked with NASA and has developed self-sustaining systems designed for space travel. Thankfully, she's done a 180 and has her sights on enabling a more sustainable planet. So please welcome Brittany. Brittany, I'll give you the opportunity to share as well your background and your organization and company. Thanks for being with us.
Awesome. Thanks so much, Noelle. Really excited to be here. Nice to meet all of you. I've been looking forward to this, so hopefully I'll get to meet some of you in person. And hello, and nice to put a name to a face, Doug. So yeah, nice to see you there. Yeah, my name is Brittany Zimmerman. My background is in mechanical and aerospace engineering originally. I designed aircraft for a good deal of time before NASA stole me out of the aerospace industry and really transitioned me into the outer space industry. I originally got brought on to look at the design and manufacturing, specifically of greenhouse modules for inflatable lunar Martian habitats, which was really synergistic with my graduate work, which was in bioregenerative physiochemical hybrid life support systems for long-duration space flight, which is just super nerdy way of saying that I bridge the gap between nature-based approaches that our scientists like to take at NASA, utilizing living organisms to keep us alive in space, and more of the engineering approach and the NASA engineers who really like to utilize things like rotating machinery, chemical reactions, filtration systems, things that do not mutate in highly radiative environments is the key part there. And my bailiwick and my strong suit is really the integration of both, how I leverage both the advantages that nature-based systems give us and the advantages that more of the technological approach give us in a hybrid or synergistic nature versus technology approach. And my strong suit is in everything that keeps human explorers alive. So the robotics parts of missions are not really my strong suit or my forte. I'm really in water reclamation, technologies, air revitalization systems. I'm also in things like nutrient cycle, food production, radiation protection, thermal concerns, pressure and temperature, things along those lines. So if it's part of keeping the human alive, that's really where my interest and my expertise lies. So I would say it was a pretty good fit. I got to develop a whole suite of different technologies. I think one of the things that kind of gave me my claim to fame in the NASA realm was a specific technology that I named Stool. And I named it that for a very specific reason, and that is I focus on astronauts' fecal matter. So sorry to anybody who's snacking right now. But what I started working on was the redesign of our space toilet systems. So what I do is I extract the water from the feces. I make it fully potable again after it's reclaimed, and then I utilize the dried biomass on the back end of that system as a filler and additive manufacturing processing. So we can actually 3D print commodities that we need as replaceable components for our mechanical and engineering systems, utilizing the materials that are produced from our regenerative biological systems and then our anatomical ones that is typically jettisoned off the side of a spacecraft or off this, placed outside of a habitat and considered waste. So we're really excited about all of that. That and a whole other suite of technologies that I developed really landed me as the principal investigator, the youngest principal investigator accepted through the NASA program, and really became a platform by which I could leverage to bring in large amounts of funding and lead different teams through the development of technologies from initial concept, right? We call it a technology readiness level, which is just a gauge of maturation for different technologies, and a 1 being an initial concept or an idea, all the way up through a 9, which is really like integration and commercialized, proven technologies. So I really like to start at the beginning and see it all the way through. So I have been fortunate enough to develop technologies that are currently on the International Space Stations, got patents that are currently selected for the Artemis program and being developed into the systems that will be landing us on the moon here in 2025. Habitats that are slated for our first visits to both the lunar and Martian surface, and a whole slew of boring stuff for the Department of Defense. But in 2019, I had a pretty big existential shift, primarily due, I would say, to 2 big things. And number 1 is water. So I'm an avid traveler. I like spending a lot of time in other countries. And one of the host mothers that I was staying with, unfortunately, contracted a waterborne illness. And for me, that was really hard to come to terms with when I had the capability of providing clean, potable drinking water to people in the dead vacuum of space and years away from our planet. And also I design air revitalization systems. So I was first asked to design an air revitalization system for a spacesuit. So as humans exhale, CO2 partial pressures build up. I work on scrubbing those and regenerating oxygen's partial pressures so that it's easy for us to breathe and there are no contaminants. And so I did that for a spacesuit, then a large spacecraft, and then I was asked to design that for the habitation of about 1 million people on the Martian surface. The Martian surface is comprised of about 95% carbon dioxide in terms of what the atmospheric composition is. So that really equated to me developing global level systems for developing solutions for greenhouse gases that could turn that into something useful or breathable for our human spacefarers. I had a lot of obstacles put in place when I wanted to start reaching back and start developing that technology not only for space applications, but bring them here for terrestrial human betterment. So I decided that was probably an endeavor best made alone. So I decided to step away. At the time I did that, I was managing a group at Johnson Space Center, a group at Boeing, 2 different university departments, and 3 public-private partnerships. So I had a very large group, and very grateful that when I decided to step away and start switching my focus to terrestrial applications, a good number of people came forward and said that they would like to join me on this new endeavor, which was really exciting. So that was really, I would say, the birth of Yame and what we're doing now. We're now over 230 graduate level experts from more than 50 countries, and we've come together and said, okay, we accept responsibility for sustainability. We've given, we spent a lot of time assuming that other people are working on this problem, and, there are no solutions that are scalable and up to par with what we think needs to happen to put us on the right path. So, I would say that's really the uniting factor between all of us. Like, we all take that personal responsibility, but we came together and we started developing climate technologies. We leveraged a lot of technologies from the different industries that we come from. So of course, me being heavily from the space industry, I leverage a lot of my technologies and designs from circularity of our space programs, and I work on reapplying those. We have a lot of people from a lot of different industries also on the team, though, that do similar fashions, and we work on integration of those different ideas and the maturation of those. So we did that. We developed a lot of different ideas. We tested a whole bunch of different ideas, and then we built those up. We third-party verified the ones of interest to us, and are now working on building a facility at scale for community implementation for the first full time. And what we do is we bring in atmospheric air, we bring in oceanic water, and we bring in waste feedstocks. And the waste feedstocks are really community dependent. So different communities have access to an excess of a lot of different wastes. That can be municipal waste, it can be industrial waste, it can be commercial waste, it can be agricultural waste. The only real requirement is that it's carbon based, because we're really looking at balancing the carbon on a global scale. So that is the primary element of interest here. And we're really looking at direct removal of carbons both from the atmosphere and from the ocean. So what we do is we bring those waste products in. We take the longer carbon chains or the pollution and we break them down into their base elements, and then we devise ways of putting those back together so that they're producing only materials that are useful for humanity and that are sustainable and produce no waste streams. So we really worked on focusing on that problem for the last year, and what we do now is we really have looked at nature as our inspiration, and we say, okay, nature doesn't produce a bunch of waste either, so what is she doing with everything, right? And that is, she's producing minerals, she's producing atmospheric air, right? She's producing water, and she's producing soils. So we really took a similar approach, and we wanted to mimic that, and that's exactly what we do. So we produce 4 main commodities out of the back end of our system. We produce a net negative concrete product as one of our main commodities out of the back end. That net negative concrete product is very unique and really special in the specific industry. It is not calcium oxide based at all, so it is not a Portland cement based product. And what we do is we produce a material that is actually recyclable in and of itself, which is exciting. So we can actually lay material, pull that back up later if we want to repave a road, or we want a new tarmac or a new foundation, or whatever it happens to be, and make that curable. We have permeable solutions as well that allows water to actually move through the material, which is really important in terms of large-scale applications of pavements, foundations, ports, things along those lines, because right now we have water that needs to be redirected in large quantities. We typically route those into our sewage systems or drainage systems, and the water is not moving the way through the geology and into our aquifers the way that it's supposed to. So it plays a big role, obviously, in watershed. We then also produce it in a way where no mining is required whatsoever, which is really novel and exciting. So there's no mining of any resources needed. So in this particular case, it is all sourced from on-island waste. So that really helps in reducing the reliance on offshore materials, which is important, certainly for island nation implementations. And then additionally, it releases no greenhouse gases in its development. And of course, it's our storage mechanism for a lot of the carbons that we're grabbing out of the environment. And it stores those carbons for millennia in a way that doesn't re-release the carbons back into the environment and also isn't requiring any geological storage, which has induced seismicity issues and a lot of other concerns around it. Then we actually extract the higher grade carbons and the nutrients in terms of like nitrogen, phosphorus, etc., things that are very important for plant growth. And we don't allow that to be locked away or stored in our concrete material. So we produce a biochar material out of that. And for those of you that are familiar with biochar, you can think of it as a sustainable alternative to fertilizer in layman's terms is the way that I would put that. But essentially, it's a sponge-like material. If you look at it under a microscope, it's very porous, is what I'm saying. And it does a fantastic job of reducing the amount of water we need for agricultural lands, increasing yield of our crops, and also entrapping toxins that were previously applied through fertilizer use, pesticide use, which helps stop the motion of those from going into our groundwaters and very importantly also into our runoff, which is killing our reefs. So that's what we do there. We produce two major byproducts in the system also, which is clean potable drinking water and green hydrogen. I heard some hydrogen talk earlier, so I know there's some folks interested in that here. And the really interesting part about that is we really get to dial up and down our solutions for different communities. So we can produce more potable water or more green hydrogen depending on the need of different communities, whether they're, have major water needs, whether they have major, energy poverty needs, or a mixture of both. So we get to do both of those. Each of our facilities can scale very large. We looked at implementation, for example, in Savannah, Georgia, and that can scale to remove 1 billion tons of carbon dioxide directly from the environment annually, which is really exciting if you're in this sector at all, because that is 5 orders of magnitude more than the rest of the world is doing combined right now in terms of direct capture. So it's really, really exciting. And really our ultimate goal, in the long term would be to develop enough of those facilities, which would be, if we built them all at that scale, it'd be about 42 facilities that we would need worldwide in order to be removing more carbon dioxide than is anthropogenically released annually, which means, right, of every CO2 atom or molecule that's being released globally from every single human initiative is being removed directly through the systems. So that is a humongous move towards achieving, I think, what we're all trying to achieve globally, which is really important. So yeah, that's what we're working on right now. We really have a large number of countries that are represented on the team. So as you can imagine, as we went through piloting and down select, everybody really had a pull and really wanted the technology to first be built in the countries where they live. So we had to get pretty scientific about it. So we actually built up a decision down select matrix and said, okay, where can we do the most social good, right? Where can we see that there's waste management issues that are building up? Where are there needs for energy solutions? Where is there a lack of access to clean drinking water, right? And so on and so forth. We really built all of this into a matrix, and we were pretty shocked because the results of that analysis had the top between 70 and 80 locations being island nations around the world. And we had our eye on island nations, but we didn't realize the huge gap or between the issues that are being faced by island nations and what's happening at least in coastal cities, which we were also looking at addressing. So we started looking at which island nations we really wanted to address. We had a few people on the team who actually grew up in Hawaii, and they made the case saying, why would you offer the opportunity to be the leader in sustainability to another country before you offer it to your own home, right? Which is Hawaii, right? Part of the United States here. So that really resonated with me. So we talked through that option and we made the decision we would spend 30 days on Oahu, 30 days on Big Island, 30 days on Maui, and 30 days in Kauai, and we would gauge it out. We would just showcase what we can do. We would go with open ears. We would see if we were a cultural fit or if there was any invitation to proceed, or also, you know, if any like major red flags came up and things needed to be changed and we needed to be agile with our systems. So that was really our intent. We spent still is our intent. We spent the first 30 days on Oahu. We built up some really strong relationships with some different communities out there, and I think we had some paths forward that are, you know, are of interest in pursuing, should that be the best move. Then we moved on to Big Island. I'm currently on Big Island. I'm actually in Hawaii. I'm staying in the volcano area right now. With a really awesome woman, Suzanne Woolley, if any of you know her. She is fantastic. So we're down here in Volcano right now and really spending time evaluating what's going on in terms of status quo currently on Big Island, what opportunities are here, if there's, you know, a social license to proceed, you know, if the problems exist that need to be solved, and whether, you know, there's interest in the specific solutions that we bring forward. And we've been really blessed with some of the connections that we've been able to make, and there's just been a lot of very transparent and wonderful communication across the board in terms of a lot of the problems that, you know, are being faced currently on island, and very good reception in terms of, you know, having open ears, I think, by both parties in working towards maybe some possible solutions that could be manageable specifically for Big Island. I started doing some more research since being here, and Big Island has really, you know, been more and more attractive to me because it's really, really special when you look at it, even in consideration to the other Hawaii islands. If you look specifically at the greenhouse gas emission rates versus its sequestration rates. It's in a really beautiful spot in terms of at least what's being reported, where about 3 million tons, so 3 megatons of greenhouse gases are being emitted, and about 1.5 million are actually being sequestered. So we're only at a negative about 1.5 megatons for this entire island, which puts us in, I think, a pretty unique scenario where we could build up the solutions at a scale that actually would make Hawaii Island, Big Island, the first net negative modern civilization, which is really, really exciting to think about. And one of the things that has been interesting, I think, in terms of, you know, learning about what's going on here, is there's just been a really, and I like to say, like, almost an ease of communication amongst the approach that you know, I think we have in terms of a system level approach that I haven't experienced in a lot of other places thus far. You know, in talking to different investment groups and people who are potential partners and collaborators, when I'm looking at, you know, the UAE or Savannah or other locations, everybody needs a lot of convincing on the side of, you know, they say, oh, why don't we just piecemeal this, right? Let's just do the concrete part. Let's just do the hydrogen part. Let's do the part that's most profitable. And for me, you know, it's trying to wrap the mind around, hey, this is actually a circular solution. It's cross-subsidizing each other, so that buys down risks, but also is the answer to why it's so sustainable. There isn't a waste stream coming out of this system because we've found solutions that utilize anything that is an effluent from the system as an influent, right, to the next. And here it's been really a breath of fresh air because there's already this sense of, like, responsibility for environment and taking care of the land, and almost a system level thinking that's very inherent here, where it's, oh yeah, of course everything's connected and everything, you know, affects other systems, and it's really beautiful, and it's really, you know, spoken to me on that level, which I feel very receptive of and excited about. So yeah, I met with Noel, so that was really exciting, and I think we got some time to talk through some of the initiatives of SEH. So I'm really excited to learn about, you know, a lot of the things that you guys have going on here. I know you guys are really focused, obviously, on the energy side of things. So the last thing I do want to say about the system, because I feel like it's, yeah, an inherent question that will certainly come up is, right, how energy intensive, you know, or how energy efficient is what you're working on. And one of the things I would love to share in this sense is our system actually produces all of its own energy. So it is a potential off-grid solution. In the process that I spoke about where we break down those long carbon chains, it's actually an autothermic process. So you do need a spark of energy up front, but it's kind of a chain reaction. Once you get it going, it keeps going. And every time those break down, it releases a large amount of thermal energy. That thermal energy we actually capture and convert into our electrical energy, and that electrical energy is actually what powers our entire system. We have had discussions about sizing that system larger so that we could build up a microgrid and store any of the excess energy to help supply renewable energy. That I think would have to be a little bit of an add-on or a delta to what the current process or current plan is. Because right now we have sized it really to be extremely balanced. So we produce about the amount of electrical energy that we need to utilize in the system, both in terms of peak and in steady state operation. But it is certainly something of interest. I know also, Noel, we don't have to jump into it right now, but I have a lot of strong opinions, I will say, in terms of, you know, different types of renewable energies on both the solar, the wind, the geothermal, the hydro, the nuclear approaches. So I'm very open to discussions on all of those fronts as well. But really just wanted to say thank you for the opportunity to talk to you guys, and really excited to hopefully get, you know, an opportunity to collaborate on some of this, because I definitely see some synergies, at least in direction and ambition.
Brittany, thank you very much for that. That's quite a bit of great stuff that you just went through, and I imagine that there are questions that folks on the call here have. So maybe what we can do is just go around the room and see if anyone has any questions of Brittany about you know, the technology, the opportunities. I'm pretty sure that there are. Oh, Des is back. There are questions that we have. So why don't we just go around the room?
Sounds awesome.
Okay, you were right. The first question that I had was what's the net energy consumption of the system? And you answered that. That's a really incredible achievement for it to be self-sustaining. And I'm curious. I mean, it does so much. I mean,
yeah,
the net benefit, I mean, in terms of how it affects life as we are, certainly exceeds the measurable volume of energy it might generate. I mean, that's a component of what we do. But I think the cell phone has got its mic on, and anyhow, so I mean, when you talk, you had just mentioned that it's possible to scale the system to a point where it could produce surplus energy, storable energy. Is there a way to quantify that relative to, say, a community's needs? And is this something that could sit in parallel with another, you know, with say a system like geothermal? And another question that I had was, in particular, because we are focused on geothermal and what it can achieve, just wanted to get your sense of how you view geothermal as an energy source in general. So those are my questions for now.
Awesome, Peter. I'll do my best to hit all of them. If I accidentally skip something, just rein me back in. But I'll try to do them in order here. In terms of the ability to scale, right, and build up a microgrid for energy storage, that's going to be highly dependent on, I would say, the makeup of a community. So, right, as we look at what our inputs are waste. So, we don't want to have to generate waste in order to produce electrical energy, right? That would not be a sustainable solution. So it's really just about that balance, right? As we look at scaling, is there an excess amount of waste that's already naturally being generated that could then, instead of being a waste, be an energy source, right? That is a non-pollutive energy source, a renewable and continuous energy source being the key there. That is an option that makes sense, right? And then it's more of an economical question. Does it make sense to put in the CapEx upfront to oversize the system and build up the microgrid in order to supply that or not? Because, when you're looking at PPAing, right, or providing energy at any size, you really need to be able to, look downstream and say, is this actually a benefit for the community? The community, of course, always wants to be sustainable, but if it costs a whole bunch of extra money because your CapEx is super high and they're paying more per kilowatt, I mean, that's going to be a problem. You're not really doing the locals a favor who are living here by taking a solution like that. So it's really about balancing how much excess waste there is in communities. And like I said, that's a lot of different waste. That can be plastics, that can be, that could be legitimate fecal waste, right? So sewage is a possibility in there. It can be agricultural waste, right? It can be a lot of different things. So it's just looking at, do the logistical burdens and the CO2 penalties that you pay up front plus the additional CapEx outweigh, or is it, benefit to the community to actually build the system to oversize that? And those are tools we've actually already built up. So those evaluations can be done. It's just about having a clear idea about, all of the waste streams and what's happening with it currently on the island. And I think in my particular case, being less ignorant on the way that the power is currently generated on island and what the status quo is in terms of, the energy sector as is, because that's the only way to know if we're doing something that's better than what the current state of the art, implemented technologies are as a benchmark. So, I hope
Brittany?
that speaks to that. Yes.
Yeah, sorry, I just wanted to add before you move on to the answer to the next question,
Mhm.
as far as inputs go, and I totally appreciate that, assessment of the need to assess what the waste stream is to be able to answer that question. But the island is actually this filter for, or I don't know if filter is the right word, but there's a ton of plastic waste that ends up on the
Yeah.
shores, right? Especially on the southern part of the island. And there's a tremendous amount of plastic waste out in the ocean that because of the currents will end up here. And, I think that's an important consideration. Anyway, just wanted to add that.
Yeah, absolutely. And plastics are definitely carbon-based and a source of energy, right? There is energy potential within there. So that that is a potential feedstock that we could look at utilizing. The thing there too is, right, we want to make sure we just stay away from sizing a system so large that anybody is incentivized to produce waste. Right, that's the catch-22. So
Right,
it's making
right.
sure that we're sizing it to tackle the waste that exists and what the steady state is, but never to incentivize the generation of waste.
Of course, yeah. I mean, it's almost like having, the conundrum you run into with biofuels. I mean, are you going to sacrifice food production for energy production? And that
Right.
ends up being
Yep.
being an argument. And if I understand kind of in the realm about the scalability, affordability for people who are just working for a living is a very important metric. If I understand, that's something you mentioned within there, is that how does it affect the economics of the surrounding community?
Absolutely.
So
The socioeconomic
would I
impact.
be, yeah, so would I be correct in saying that the system itself is a throughput to ecologically manage a waste stream, and that it is able to sustain itself without needing additional inputs that could be used or would otherwise be used elsewhere?
That's correct. So, right now, right, I think this is something people have talked about before. They're like, oh yeah, why don't you just burn wood or, other things that are really important in other industries, right? Those are not the things that we would be after in this system. This system is really meant to button up the waste streams that are currently polluting and causing havoc environmentally in different realms. So we do bring in like green waste, but that's typically focused on things like invasive species, management reserves, right, from mitigating wildfires, things along those lines are things that we do consider bringing into the system, but only if they are waste streams in their true sense, right? They end up at a landfill, they end up getting tossed, they end up in a place where they aren't utilized or even able to be utilized in other fashions. If there are better approaches, for those goods, we're advocates and love to support those industries and help those industries thrive and those companies and solutions thrive, because this is really about circularity and the long-term play. So, yes. And oh gosh, Peter, you had one more.
Geothermal.
Oh yes,
What's your view on
geothermal.
that?
Thank you,
Yeah,
thank you, thank you. Yes.
no worries.
So yeah, we've actually dove pretty deep into geothermal. Like I may have mentioned, we developed over 30 full system level concepts before down selecting to this specific approach. And the energy, of course, is a really big part of that. So I will start by I'll just get off the soapbox that inherently is going to be addressed. I am not an advocate for solar and wind technologies. And the way that I decide what I advocate for is really scientific based in terms of life cycle assessment. So when I say I advocate for something or I stand behind something, I'm really talking about what is the impact from cradle to cradle. So that is, if we look at how manufacturing is occurring, right? And for us, both wind and solar don't really stack up in terms of the issues that they cause on the manufacturing side of things, the life of the product, and then also the disposal side of that, and then what it takes to move that into the exact, the beginning of the system, so that we can look at that full circle. In terms of wind and in solar, I'll get on that soapbox some other time. There are a lot of other really big issues associated with the implementation of those technologies. So I naturally, and the team naturally, are really interested in things that have a negative LCA. So we're looking at things that are beneficial. And for us, when I talk about sustainability, the definition that I go by is that every single person on the planet could do it every single day, and we would either not be in a worse situation or we would be in a better situation because of it. So, that's really what I gauge. And so when we're looking at the LCAs, that's really right, our scientific benchmark and methods for being able to evaluate that. It's cumbersome, I understand that, but it's also extremely important in truly evaluating. So we dove into geothermal. I was going to say we dove into a deep analysis on geothermal, on nuclear. We dove very deep also into damless hydropower solutions as well. Both wave and tidal can, I think, be tacked onto that additionally. But in terms of geothermal, it's definitely a solution that we were drawn to. We actually developed a solution that worked in tandem with geothermal applications. As you may know, geothermal applications actually produce a brine. So we actually produced also a system that would actually mine that brine for like lithiums and other things that you actually find in geothermal applications, process those brines so that there isn't a waste product, and we rather liked that solution. We came to Hawaii with sort of both in hand. We had to develop the waste to energy system because there's a lot of places we are looking at implementing that don't have access to high enough grades of heat that geothermal is a solution, right? There are places around the earth where that happens to be the case, just because the logistics of going deep enough in those locales just don't make a lot of sense. So we kind of had this two-pronged approach. We really enjoyed geothermal. Coming to Hawaii, I think we definitely, we're very receptive to a lot of the feedback. And for us specifically, right, we started realizing the waste being a very big issue here with the lack of recycling problems, with actually shipping a lot of, the waste products, off island and having to pay not only for the import, but then also for the export. We started seeing the waste management solutions kind of build up in favor. So for those reasons, we decided to move towards the waste management solution and prioritize that. But speaking to geothermal, I think in places where it's culturally and religiously a match, it's a very great technology as long as you can overcome a few things, right? Geothermal has induced seismicity concerns associated with it. So understanding those seismicity issues is a big part of it. That's evaluations that we do also internally on the team that are very, very important. And also understanding kind of your brine management side of things as well. So I think if you get those two things in alignment and in check and everything works out, it's a fantastic solution, in the places where it makes sense. And my approach to energy is definitely not this energy is better than this energy source. It's more of a let's take into account anything that really is net negative and truly is sustainable. And I also like to throw continuous on that list because continuous energy just makes a lot of sense for the way that we utilize energy as a society. But as long as it meets those thresholds, then it's great. And different types of solutions that meet those requirements are going to be better for different communities and different solutions. So really moving away from a centralized approach where one energy source reigns supreme and moving to a more decentralized approach that really puts the power of the communities back into the hands of those communities and allows, obviously, for a lot of, I consider it safety reasons also, moving to a more microgrid solution and allowing the geology, the culture, the religion, the access to feedstocks dictating which of those renewable and continuous and sustainable energies make the most sense for each community.
I have a quick question on so it sounds like the assessment of the waste stream is an important consideration for, if you go into a place and there is no waste stream, which is impossible or very little,
Yes.
then the solution is going to be different, right? So
Correct.
presumably we're seeing that here, and I don't have the figures, and maybe Riley or Doug, you have that, but there's a ton of stuff that's going into the landfills on a daily basis, right? Being actually trucked over from Hilo all the way to Kona, the Kona side.
That's correct.
And presumably, not presumably, but the issue is magnified on islands like Oahu, right, where you just have even more garbage and stuff that needs to be disposed of. So my question is, based on your assessment so far, how much of the community's energy needs can the waste stream address? Is it 50%? Is it, do you have an idea of that based on what you've learned?
Yeah, that's a really great question. Just because our system is really targeted to balance itself, right? We haven't dove very strongly into providing the microgrid solution. We definitely can do that. Like I said, we've built up first order tools to be able to evaluate that. But the community hasn't really asked for that yet, but it's something we would be happy to, initiate and kick off and look into. In terms of what is capable, though, Noelle, I think one of the big misconceptions, is, like this strategy, or this source of energy, can't scale. And one of the things I'd like to point to is, typically waste to energy systems can, right? Even at slightly lower efficiencies. I mean, you can look at systems that are currently just utilizing combustion. And when I say combustion, that means there's oxygen in the system. It's literally just a burning mechanism that people utilize. And I believe that's what HP is doing on Oahu right now, right? They bring in all of the rubbish and they legitimately burn it. That produces large off-gassing issues. We'll talk about why I think combustion isn't the right, methodology or path forward. any time that you guys are interested in that conversation, but different soapbox for another time. But what it does showcase is that that energy source just on Oahu is what is providing a large amount of the electrical energy right to the island. So there is a substantial amount of energy in that, and combustion is much less efficient than more of the thermal-chemical conversion types of technologies that I'm talking about right now that don't produce those exhaust streams, right? That don't release any of the carbons back into the environment. So it is very significant. I definitely think pairing that though, like waste to energy with another energy source really is the better plan long term. Like I said before, just going back to not incentivizing the production of additional waste in order to power a system. I really believe it's important to size the system correctly to deal with that issue. And if there is an excess of energy, that need, and there might not be, but if there is that excess energy need, there's two ways of dealing with that, right? One is you can use the system to produce green hydrogen. Green hydrogen, I'll let you guys argue about the fuel cells versus a combustion. Yeah, that's the age-old argument.
Right.
But regardless of the approach that you want to take, right, there is also a mechanism by which we basically are storing, right, our excess electrical energy in a commodity. So it's maybe not a traditional storage method, but that is another energy source that can be utilized from waste to energy that is sort of supplemental, right, or complementary. But I do think it is important to have another source that is not reliant on the waste feedstock to supplement also larger communities. For small communities, I doubt it would be an issue at all. But for larger communities, in the case of peak non-steady state operations that go beyond, what your initial analyses or your growth might project, to have something that is not that can be utilized without the incentivization of additional waste production.
Brittany, this is Dan going up. In a previous life, before I got into the utility business, I worked for the Department of Navy, so I have an idea what it's like to get things space certified. Because submarines and submarines and spacecraft have a lot of the same things in common. So
they do, yeah.
Yeah. So you know what I'm talking about, okay?
I do.
So one of the trickier issues, because understand I was one of the guys, I was building things and I have to get it submarine certified to stick it like an Ohio class submarine or something like that, right? But one of the things that used to always jam me up all the time is it has to do with chlorines and fluorines.
Yep.
I mean, because you know how human beings are. They're always gonna buy something online or whatever, and there's always going to be the introduction of chlorine and fluorine. And most of you guys don't realize this, but those toxic substances in a submarine become a big problem, and trying to deal with that. And how would this system deal with that sticky issue, considering a lot of those chlorines actually turn into carcinogenic things, and they're not easy to, the compounds are not easy to deal with. How do you deal with that? What have you thought about that?
That's a fantastic question, Dan. I love it. Yeah, I spend a lot of time talking about those two compounds, so you're speaking my language here. And for us, it's a lot of electrochemistry, as you may or may not imagine. But,
the electrochemistry, I get that. The chlorine electrochemistry, okay, but fluorine, all electrochemistry and fluorine is nasty. Just
it's
plain
rough.
nasty. Yeah.
It is extremely difficult to overcome, but there definitely are solutions built around it. And one of the exciting parts about that, right, is you can utilize both of those substances in molecules that actually are useful for humanity at the back end also. So it's really just a reframing of, what do those substances mean when they're standalone, and what can it actually be combined with that we have access to in our waste stream that actually produces something that is useful for humanity, right? And that's really what we look at in terms of a lot of different things. And that's why analysis of the waste feedstocks are so important, right?
Right.
Are there heavy amounts of those sorts of chemicals in in it. But there's a lot of solutions around it, definitely, right? For example, you can grab sodiums and chlorines and you can make salts out of them. That's fantastic, right? We have a large need for salt in a lot of different applications. So
Yeah,
that's
a lot of
fantastic.
your calciums, potassium, sodiums are great for sequestering that type of material, making it
Exactly.
safer. Yeah, on the utility side, for the longest time, we had problems with PCBs in the transformers. We used it for transformer oil, and about more than 30 years ago, they made the switch over. And these days, all the transformers have just mineral oil inside of them. Okay,
Yeah.
but it was difficult just getting rid of those old transformers and the PCBs because it was just a waste hazard nightmare.
Yep.
So that's why I'm asking about the chlorines, because every time I'm in the utility business, we're always some old power plant and like looking at this big substation transformer, like, okay, what's in it? Oh no, it's a PCB thing. Oh, there's a giant headache. And you're talking about 100-ton transformer you got to get rid of somehow. I'm like, oh, what have I got to do with this thing?
Yeah.
So yeah, if you got some comprehensive, how do I deal with this hazmat issue? And because human beings do stupid things, not then they don't know, they just don't know. So yeah.
Yep, for sure. But great question, Dan, because we spend a lot of our time dealing with exactly those substances and figuring out how to put them back together into our materials. All right, what else you guys got?
Yeah, I just want to
Well-
do a quick time check here. So we're about 5 minutes to the end. We typically can go over if there's, there are questions, but Brittany, obviously we respect your time. If you have a hard stop, we'll honor that. Can you just let us know, are you able to
I'm
stay
good
on
to
for a
keep
few minutes?
going. Yeah, I'd love to
Okay.
answer all the questions you guys have. It's
Okay.
important.
Yeah,
Okay,
I've
thank
got
you.
I've got one more, which I
right.
mean, for me today, whatever the conundrum we face ultimately boils down to, I mean, all of the kind of the existential issues, but it also has to take place within a world that can function within economics as we know it. And so my question is how, I mean, it's clear to me that the depth of the system and what its capabilities are that you're discussing are, I mean, could easily be the subject of a PhD thesis, and then still not get into everything. But but the economics in the world of economics, how does it fit with what we do today? Is it something that will make life more affordable, or is it something that will be something that, I mean, although it sounds very complex, something that will add to the complexity and therefore the cost?
Yeah, great question, Peter. And this is something we've spent a lot of time on, both on the consumer end and on the business to business end, because it's really important, right? You get opposition in things when you're taking bread out of somebody else's mouth. So that's a big part of this, or making it more difficult for some people to put bread into their mouth. Yeah. So this is something we've spent a lot of time looking at and discussing. So we do have a very specific and I think unique approach in this sense, and that is we approach this where we produce the goods that are cross-subsidized cheaper than the traditional non-sustainable approaches can. And that gives us a really unique ability where we get to offer those goods, right, to the people who already have a large customer base. So we're not interested in coming in and being like, the concrete manufacturers of Hawaii, right? I mean, we'd have to build up all of our customer base. We'd have to do a whole bunch of stuff that increases complexity and cost. There's already organizations, for example, that already supply those goods to people on the island. They have relationships. Those things are already built up. So really, it's the position we take is, hey, let's give these people an option where A, they're not having to import from off island the resources. B, they have an option, that's not more expensive, so it's not more taxing. And C is helping save the environment and putting us in a sustainable place, all in the same, decision. So it makes it, our goal is to make it a no-brainer, right? It's making it easy to do business with other businesses. That allows for status quo on their end, or those companies ultimately get to make the decision on the prices that they, can offer their products to the consumers at the back end, because, the hope is that they're sourcing it for cheaper and they'll be able to see that on the consumer end as well.
Right. One of the things that you mentioned that I think is critical in establishing any plan that involves our neighbors is that it be a long-term view, that it not be short-term,
Yep.
and the reality that economics as we've known it cannot continue. That is not sustainable.
Yes.
And so this, what I'm hearing today is really, really exciting, because it's essential and different, and it takes into consideration, it seems to take into consideration that that we have to be self-reliant, and especially on islands. And I find it very encouraging that when you did I have no dog in this, I have no dog in this fight, that you came up with the fact that island nations and island states are the canary in the coal mine.
Yep.
Okay, so this is awesome. Thank you.
Dave.
Thank you, Peter.
I'm inspired.
Dave, you have your hand up?
Yes. So Brittany, hi, David DeLuz Jr. I'm actually very interested in water quality. And so we've got two major issues. One, of course, in Red Hill and Honolulu.
Yes.
That has immediate need for something that you present here as far as analysis and solutions. And which, by the way, I think, and this would go to Dan, the Navy is in a huge pickle on this one. And,
yeah.
And apparently Congress is willing to fund this to astronomical heights of up to $1 billion in remedying this solution, as far as taking the fuel out and then having to remediate the damages done to the aquifer. But that being said, one of the issues that have been surfacing as of late, in other words, in the last decade, and is going to be coming under extreme scrutiny by EPA, is the forever chemicals, the PFAS compounds.
Yeah.
And so, this is an immediate concern. I mean, if anything, once our clean water is threatened, and I believe potable water is at only 2 or 3% of the world's water. I mean, it's so minuscule when you think, and of course, the other thing is when you look at desalination, I mean, the side effects, not only in the hazardous compounds that are created, in addition to the huge amount of energy that's needed for that particular process, is socially and environmentally unjustified. But putting that aside, clean water is becoming a rarer commodity than fossil fuels. And so we may run out of clear water before we run out of fossil fuels. And the only reason I'm aware of this, I'm on the water board and been exposed to some of that. But so for me, this would have, and the sad reality is we can take reclaimed water and get it to be potable, but not if it's got forever chemicals in it.
Yep.
So that's my thing. And how can you help us to address that concern that we have right now, actually?
Yeah, awesome question. And water is very near and dear to my heart, right? I spend a lot of time designing water reclamation systems specifically for space applications. And over the last few years, I've been looking at how can we apply that at a larger scale to the processes that we are currently implementing. And for me, right, I only about a year ago, really started to learn about the water situation in Hawaii, as we started, looking at what solutions here might look like. I had no idea. We have this idea that it's just this flush, flowing, island with a lot of water. And it was really a surprise to me diving in and learning about, the Red Hill issues, a lot of the issues that I think unfortunately all the islands are facing in terms of water quality and water treatment applications right now. And PFAS is a really big part of that. the work that I've done specifically, we've really targeted, right, a couple of different types of technologies, right? We have membrane-based technologies, we have absorbent-based technologies. There's lots of different ways, right? Distillation type technologies that we can address what water quality is, and they all have different effects on different particulates, on different contaminants, and there are ways of pairing those together, and there are ways of addressing PFAS. So it's something that don't freak out too much about it, because there are proven solutions to PFAS. And that's really important, especially when we look at what the implications are of taking things that are generally viewed as waste and working through the certification and the testing process to, showcase that those are indeed actually very clean and potable, right? That was an issue we faced on the International Space Station, for example, where, the astronauts don't want to reconsume the waste, the water that's reclaimed from the waste. And actually, for a very long period of time, I think up until today, the Russian side of the ISS does not consume that because of psychological reasons, even though all of the testing, the water that we're drinking out of the reclaimed urines and feces on the International Space Station is an order of magnitude cleaner than what comes out of anybody's tap anywhere in the United States. So we have the technology to do that. One of the things that we actually started looking at specifically, in our team is related to this, right? We have developed the first desalination system that produces absolutely no brine, right? That's insanely exciting. And one of the reasons we've gotten just a large amount of attention in the UAE area, in the Middle East area, because 98% of their water is currently being produced through desalination practices. They're producing brine, and if you guys don't know, a lot of desalination practices are about 10% efficient. So we're actually getting 10% water, 90% brine that comes out, and that brine is highly hazardous and toxic, and they actually dump that back into the ocean, right? They're dumping that into the bays, and it's wreaking complete havoc on the Persian Gulf and a lot of other places around the world, because they need very large amounts of water, and only 10% of what they're bringing in turns into potable water, and then they have all of this waste that they're dumping out, right? So there's been a lot of interest specifically in this technology because it's a no brine solution, right? It's really, really, really exciting. And that provides a whole bunch of very cool opportunities for us, right? One of those opportunities, and I had no idea how many opportunities until people started coming up and saying, hey, we want this solution for, and then I'm like, I never even thought about using the water in that way. Like, the reasons we need water are so diverse, right? In Savannah, they don't have enough, they're economically in a bad spot because they don't have enough water to supply the manufacturing, and the manufacturing jobs coming in is what was, keeping them alive, and now they're legally not allowed to bring in manufacturing facilities, so they wanted potable water to feed manufacturing facilities. Then we go to other places and they're actually, been wrecked by hurricanes, so their wetlands have been destroyed. So they're actually looking at the utilization of waters without PFAS and other forever chemicals in it, actually to push back oceanic and saline water, which is now encroaching actually on their aquifers and threatening to poison their aquifers with the saline waters or with the brackish water. So I was like, okay, never thought about utilizing the water to flush into the ocean, but that is legitimately solutions that people are looking for worldwide. This also happens a lot of times in places where there's a large amount of cesspools or there's been a poisoning of aquifers, and flushing those is a thing that people look at, right? And they're like, but where do we get enough of that excess potable and clean drinking water in order to ensure all that gets out? The other thing we've been diving into is, it's pretty exciting. Yeah, talking a lot, so you guys can cut me off whenever you want to. But actually, one of the materials that we actually invented specifically for our direct air capture technologies, right? It's how we pull the carbons out of the atmosphere, actually ends up grabbing PFAS in it. So we've done a whole bunch of testing on water quality applications specifically for that material, which is just a carbon-based material for the grab and absorption, and mostly the inability for the PFAS to move anywhere else, the encapsulation of the PFAS in that. So there's just a lot of really cool stuff, and everything in our system is sourced from the waste. So like I said, it comes down again to we have a lot of options. We have so many things that we can implement, and there are solutions to all of this. PFAS and forever chemicals isn't a solution that hasn't been solved in some fields, right? It's not an impossible thing. Even, when we look at jet fuel applications in water, we have definite ways of pulling that out. The real question becomes, how do we do it sustainably? How do we do it quickly? And how do we do it economically? All of those things are absolutely possible. It's just getting a good lay of the land, and bringing the hardest part is all of the parties who have to agree to it together at the same time, and everybody shaking the hand and saying, yes, now is the time, we're here and we're going to do it, And the big part of that too is, especially in things that are a little bit younger in development, right? Having organizations feel comfortable coming up and proposing those solutions, knowing that, hey, there might be an obstacle, or it might not go perfect the first time, and the team has to stay together and make it through it, that first obstacle, because failure is part of success when you're doing something brand new for the first time every single time, and not putting the tail between the legs and running away, because then you just have another intermediate that you've created and a new disaster to solve, where if you would have just stuck with it 1 or 2 iterations, everything would have been okay. So it's really more on the people side of things than the technology side of things, because we have the technology already to do all of that.
So Brittany, real quick, and Doug, you might want to check, and Randy has this information when he was in your area, but I think about 10 years ago, and maybe less than that, a contingent from the Middle East came to look at OTEC, specifically for desalination energy options.
Yeah.
So they've been here. And so what I'm getting at is, you've got a world-class opportunity for educational research on this island. We just haven't been able to, they're all siloed. We haven't been able to get them to come together.
Yeah.
The other part is that there is a tremendous opportunity if you could share, and Richard, I'm going to bring you into this, is we have tremendous need for a net zero waste solutions for the astronomy industry on Mauna Kea. And so, that's a real issue that's needed now. And Richard has more he can share in that regard. But so whatever we do here, because the scale is so much smaller, if you can make it economically feasible, it can be extrapolated almost any place else in the world.
Yep.
So
Absolutely.
that's my 2 cents. But thanks, guys. I gotta go though. Bye.
Awesome. Thanks so much, David. Yeah, and
I'd like to ask you.
Yes.
Your organization has so much benefits that could help Hawaii County with our landfill waste, our sewage waste, and the water problems. Could you tell us a little bit about your organization? Is it a profit, nonprofit, and how many of them are you?
Yes, yeah, absolutely. So right now we're established as an LLC. So that is a for-profit organization, and the reason we do that is there's a multitude of reasons. First of all, we're really big on not only sustainable technologies, but sustainable economics. We're interested in sustainable business plans. We're sustainable communities, sustainable relationships, right? It all has to be sustainable, or you're not really meeting the intent of what the foundational principles are. So the first thing is, okay, you can build organizations, right, that aren't profitable, but in not being profitable, it's also not sustainable, right? That business plan isn't sustainable. So inherently it has to be profitable to some degree. And that's why it's actually built into our requirements. When you look at what our requirements are, is it has to be scalable and it has to be economic. If it doesn't meet those 2 requirements right out of the gates, we're not even interested in diving any further into the valuation of the technology, because it's inherently, not sustainable. So those 2 things are important. So that really leads us into the evaluation then on the business side of things, Jerry, of saying, okay, fantastic. So we have different options and a lot of different entity structures that exist around profitable organizations. What does that look like? Okay, fantastic. We have all of these options. So we started diving down that, and we learned a lot of different things. A lot of our lawyers originally were really pushing us to be incorporated, right? There's S Corp, C Corp, there's all these different incorporations. And the argument there is, oh, it's easier to get investment, you know, there's all these reasons, blah, 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 blah. But at the end of the day, we've really actually made very strong decisions to stay away from being a corporation in that sense, because with being incorporated, you have a fiduciary responsibility to your stakeholders. And when you have a fiduciary responsibility to your stakeholders, you are legally responsible to vote on behalf of finances. That means you have to vote in the best interest of your stakeholders, who are your investors. And your investors care about the profit, so you have to vote in favor of anything that increases ROI, right? Your profits. And for us, it's like, hey, we've already built it into our requirements. This is a sustainable solution. And that sustainable being the objective word there. We built this around sustainability. We built into the requirements that it's profitable. If I ever get to the point where I have to make a decision where, hey, we're still extremely profitable, but, you know, I have to take a hit on the environmental side to be more profitable, I am not going to make that decision. That is not the decision that meets, you know, our organizational principles in any way. So it becomes very difficult to make sure that the business organization then matches what your principles need to be. And that's something that we've been working on very hard. And that's like a really interesting conversation that I think we could spend another hour discussing. But I've spent a long time actually looking at how can we build a system that allows the profitability and the decision to be in the hands of the community, because they're the ones who are putting up the land, they're the labor force, you know. And how do you make sure that you don't just have a bunch of investment coming from somewhere else where all the profits are not seen by the community? So we've been working very hard at building up structures that allow profitability to stay in the community where it's actually done, where the expertise in the maintenance, in the innovation, and everything is held in the communities where it's being done, so it's not reliant on some other mega organization or corp somewhere else coming through for them, so they can't be held hostage to that. And then also, at the same time, how do we build in people who are not profitably motivated to vote on direction? How do we give, you know, that sort of power to the community to make decisions? Because in order for it to truly be a solution, and when I say a solution, it meets the technical objectives, the environmental objectives, and also the community and social objectives. It is not a solution if it doesn't meet all of those at the same time. So you really have to focus on, I think, that latter part, because often it gets excluded in the development of corporate structure. So we've actually been doing some pretty wild stuff that I'd love to have conversations with at length about anybody who's interested in that side of things, about ways of actually proxying votes to community members who have no financial stake in the actual organization, because I feel like, because I know so strongly that voting on behalf of sustainability will still allow for profitability in the corporation. So it's an LLC. That was a really, really long way of saying it's an LLC. Okay.
And Brittany, where is, can you comment also? I think Jerry also had a question about the team, right? The size of the
yes.
organization. And yeah, can you comment on that?
Yes, right now the organization is 230-esque, plus or minus 20 in either direction. We're growing all of the time, so I think we could be closer to 250 by now. We're very international, so we come from over 50 different countries, and we work almost entirely virtually. There are a few of us here on island. That's really just to evaluate whether this is a good place, and really work then on educating, I think, a workforce that would be responsible here, because our priority is to, you know, bring in as much of local forces as we specifically can to build up. And that's part of the decision on the scaling side of things too, like what can the community actually support that doesn't require a large influx, you know, of people who, you know, would have to be brought in for specific objectives or job roles or anything along those lines. So yeah, when I say we're 230, that's international. It's definitely not in Hawaii. And we're constantly growing. We're always increasing the number of expert leads that we need to tackle different issues. So, you know, like Dan was saying, hey, you know, what kind of issues are you facing in terms of chlorine? When we started facing chlorine, we didn't have anybody on the team who was an expert in chlorine, so we went out and we found like the 20 leading experts in the world who deal with chlorine issues, and we get them on board, right? We pick the ones that make sense for our objective, we bring them on board, and we work through those issues. And this is really how we organically grow. So as we are facing a new challenge that we didn't know initially was a challenge, we talk to all of the people in the world who, you know, are experts in that, and then we keep growing.
That
Thank you.
Brittany, that chlorine problem shows up not just for potable water. That chlorine problem shows up with power plants. Let me give you an example. Might get in some issues. I hope I don't upset anybody when how I talk about this, and it has to do with just plain alcohol and chlorine, because we use chlorine as a disinfectant, very, you know, and everything, you know,
Yeah.
from our clothes to our washing dishes, stuff like that. And at the same time, we human beings, we consume something as simple as ethyl alcohol. Of course, we urinate that out. And that chlorine and alcohol combine together and form these carcinogenic alcohol compounds, right?
Yep.
Well, the other place it shows up, because it's a carcinogen, you can't get it out of a wastewater treatment plant or your municipal water plant where you're generating potable water for your drinking water, but it shows up as a problem in power plants. Because in power plants, one of the things we do is we add what are called oxygen scrubbers to remove oxygen content from the water we use in steam turbines. Well, those chlorine compounds react to the oxygen scrubbers and cause lots of problems in power plants. So having pure water for the power plants is a really important issue, the quality of the water. So it's not just potable water. It causes problems. Well, you see this thing behind me? I mean, there's also steam turbines. These things are very expensive machines. And so the quality of the water, the quality of the whatever goes into this is very important to keep it working, because it's just a very expensive machine.
Yeah,
so
absolutely.
But yeah, that alcohol chlorine thing shows up in a lot of places, and how do you remove that from a system? And that's why I asked you that question.
Yeah, makes good sense. I'll add that
Yeah.
to the list of exciting ways people want to use the clean water.
Yeah.
I'm gonna. So, well, okay, we're over. You know, I'm pretty sure we would love to have this conversation continue, but there'll be other opportunities. And yeah, there's so many open questions, Brittany, still that you know, I'd love to have a conversation with. I'm pretty sure others too.
Absolutely.
So, and team, if there are questions that you have that we haven't addressed, feel free to you know, share with me.
I'm definitely going to be reaching out. So you know,
Wonderful.
we'll go from there. Excellent.
Great.
Yes, please do.
Well, thank you once again. Everybody have a good evening and a great weekend.
Thanks.
Aloha.
Thank you.
Thanks, everybody.
Aloha. Thank you.
Half a day.
Aloha.
Half a day.
Yeah, thank you, Brittany. That was really good. Aloha.
Thank you. Aloha.
Bye.